Hello everyone, welcome to this series of C tutorials. In this presentation, we will be concentrating on pointers. Pointers are the variables which can store the address of a given data. Both the data and the pointer should be of same data type. To define a pointer, we need to follow a syntax. First, we need to mention the data type, space followed by the asterisk symbol followed by variable name. For example, int asterisk pointer. Asterisk pointer is represented as contents of pointer. Pointer initialization. Just like we define any other variable, pointer is defined in a same fashion. There are two ways of using pointers. First one is making use of static pointers, and the other is making use of pointer for dynamic memory allocation. Here in a static pointer, we defined a variable, character, and a pointer, where pointer is used to store the address of variable C. Dynamic memory allocation. Pointer could be used for dynamic memory allocation with the help of malloc, calloc functions. For example, first we define a pointer, then we will assign pointer to calloc. Contiguous allocation. Contiguous allocation function initializes 0 to blocks of memory. Here we are defining 10 blocks and we are passing the size of character, that is 1 byte. Static allocation example. In this program, we defined two variables named I and pointer. In pointer variable, we are storing the address of variable I, and we are modifying the contents of pointer by writing the value 3. We are not directly assigning value to I, instead indirectly we are assigning using a pointer. The contents of pointer, that is address of I, is equal to 3. Here we are printing both the pointer and the contents of pointer. Here is a visual representation of the program that is stored in the RAM. Say the variables are stored at address 100996, that is the variable I and pointer. In pointer, we are storing the address of the variable I, that is 1000. Now we are modifying the contents of the pointer. The contents of address 1000, we are storing 3. Here the pointer is stored at 996. Inside that we stored the address of variable I, that is 1000. Now go back to 1000 and store the given value, that is 3, in variable I. This is an example for dynamic memory allocation. Here we defined a variable named pointer and we are assigning pointer to calloc 3 blocks. All 3 blocks are initialized to 0 and we are passing size of integer. Here the pointer is integer. Both should match. In pointer of 0 we are storing 10, pointer of 1 20, pointer of 2 30, and we are looping and printing the same. Finally we are freeing the pointer. Here we can see the output. For I is equal to 0, I is less than 3, I plus plus. Print the values of pointer. Finally, the memory allocated should be released, and it is achieved by using free function in C. This is the visual representation of dynamic memory allocation. Int pointer of pointer variable. Let's assume the pointer is stored at address 1000. Now we are assigning something to pointer. Here we are calling calloc 3 number of blocks and the size of integer. Here we can see at address 100, 104, 108, the 3 blocks are assigned to 0. This is what we assign to a pointer. Now the contents of pointer of 0 is 10. The value at address 100 is 10. The value at address 104 is 20. The value at address 108 is 30. Pointer arithmetic. Pointer could be incremented or decremented by adding an offset. Example, here we defined two variables, I and pointer. In pointer, we are storing the address of I. Now we are incrementing the pointer, then we are decrementing the pointer. This should work as expected, just like any other variable. Here we defined a pointer of type integer and a pointer of type short. In pointer integer, we are allocating 2 blocks of memory. In pointer short, we are allocating 2 blocks of memory. Before any manipulation, we are printing the address of pointer. Here we can see pointer integer, the last 3 numbers are 260, and here is the pointer short and last 3 numbers are 280. Now we will increment integer pointer and short pointer, and we are printing the same here. Here we can see the value of pointer integer is incremented and the value of pointer short is incremented. Finally, we will free the memory. This is a visual representation of the given example that is stored in the RAM. Here we can see address 100 is stored at address 1000. That is, pointer integer address is stored at address 1000. And address of short pointer, that could be 108, that is stored at address 996. Now we are incrementing pointer integer. Before it was 100. Now since we incremented, the address got shifted to the next address 104. Similarly for pointer short. So 2 bytes of memory is shifted. Arrays and pointers. Both arrays and pointers could be used interchangeably, but both are not equivalent at compiler level. There is a slight difference in the assembly code. The name of an array variable is the starting address of an array, which we learned earlier. You can make use of this to initialize pointers. For instance, here we defined an array variable of size 12 of type integer and a pointer of type integer. Now we are storing the address of array in pointer variable. To access the ith element of the array, we can either use array of I or pointer of I. Both are equivalent. Compiler interprets these two as contents of array plus offset. This is interpreted for an array, and this is interpreted for pointer. Contents of pointer plus offset, that is array index. This video is presented by Avari Technologies. Please to hit subscribe button to get more content. Thank you.